In this lecture, we are going to discuss about the series solutions of second order differential equation, and the content of this lecture is from the book of Das and Verma, Higher Engineering Mathematics. And in this lecture, we are going to discuss about the power series method for solving the differential equation. So let us take an example. Suppose there is an equation d square y by dx square minus y is equal to 0, and the solutions of this differential equation is y is equal to e to the power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial in this way, and y is equal to e to the power minus x, that is equal to 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial and so on. So both of these are solutions of this differential equation, and these are known as the power series solution of a given differential equation. So before going to the further discussion, we should have some concept about ordinary point. So what is an ordinary point? Let us take an example. Suppose d square y by dx square plus p into dy by dx plus q into y is equal to 0 is an example of differential equation. Here p and q are polynomials in x. Now x is equal to a is an ordinary point of the above equation if the denominators of p and q do not vanish for x is equal to a, that is p is not equal to infinity and q is not equal to infinity. So in that case, x is equal to a is an ordinary point. So let us discuss with some example, then it will be more clear that is what is ordinary point. Suppose this is a differential equation 1 plus x square d square y by dx square plus x into dy by dx minus y is equal to 0. This is an example of the differential equation. So I can rewrite this equation in this simplified format. Simplified format means the format which was discussed earlier, that is we have to express any differential equation in this standard format, and d square y by dx square plus p into dy by dx plus q into y is equal to 0. We have to express the differential equation in this standard format. Here p and q are polynomials in x. So after converting it to the standard format, the equation becomes d square y by dx square plus x by 1 plus x square dy by dx minus 1 by 1 plus x square y is equal to 0. So this is p, this one is p, and this one is q. This one is q. So now look at the denominator of p. The denominator of p is 1 plus x square. So 1 plus x square clearly is not equal to 0 at x is equal to 0. If we put x is equal to 0 here, then the denominator becomes 1. So it is not equal to 0. And as it is not equal to 0, therefore we can say that x is equal to 0 is an ordinary point of this differential equation. And same is for q also. So this is an example of the ordinary point. So x is equal to 0 is an ordinary point. Let us take another example. Suppose x square d square y by dx square plus 2x square minus x dy by dx plus y is equal to 0. So at first we have to convert it to the standard format. So this is the standard format, and you see that this is p. 2x square minus x divided by x square is p. Now if we put x is equal to 0 here, that is in the denominator of p. So if we put x is equal to 0, then p will become infinite. So in this case, x is equal to 0 is not ordinary point of this equation. So from these two examples, I think we have made it clear that is what do you know by ordinary point. Now we'll discuss that when x is equal to 0 is an ordinary point, then how to solve a differential equation. So in that case, if x is equal to 0, x is equal to 0 is an ordinary point, and that is p does not vanish for x is equal to 0. So in that case, what we have to do, we have to assume that y is equal to a0 plus a1x plus a2x square in this way, that is equal to sum of a k x to the power k, where k is equal to 0 to infinity, is the solution of the given differential equation. That is, we are assuming and that the solution of the given differential equation in a power series form. So this is the expression for y. So after assuming the expression for the solution in this power series format, we have to find dy by dx and d square y by dx square. This is the second step. This is the first step. In the second step, we have to find dy by dx and d square y by dx square. Clearly, dy by dx will be like this. If you differentiate y with respect to x, then you will have this equation, and in the right hand side, this was a k x to the power k. So this will become k into a k into the x to the power k minus 1. Similarly, you can also find out d square y by dx square, and this will become this. So if we express in summation format, so this will become a k into k minus 1 into x to the power k minus 2. After evaluating dy by dx and d square y by dx square, you have to substitute these values to the given differential equation. So after substituting the values of dy by dx and d square by dx square in the given differential equation, what you have to do, you have to calculate a0, a1, a2, that is coefficients of various powers of x. You have to calculate the a0, a1, a2, that is the coefficients of various powers of x, by equating the coefficients to 0. And this will be clear after we will discuss some example. So at last, what we have to do, we have to lastly we have to substitute the values of a0, a1 and a2 in the differential equation to get the required series. So now we will discuss an example, then it will be clear, that is how to solve the equation by power series method when x is equal to 0 is an ordinary point. Suppose this is a equation. This is the equation d square y by dx square plus x square y is equal to 0. So the first thing is that you have to express this in the standard format. This is already in standard format, because you see that it has been written d square y by dx square. So the coefficient is 1 here. That means it is in already standard format. So it is clear that the denominator of p and q is not 0. So x is equal to 0 is the ordinary point. The first thing that you have to check that whether x is equal to 0 is an ordinary point or not. And here it is clear that x is equal to 0 is an ordinary point. So the first step is that to assume y is equal to a0 plus a1x plus a2x square. That is, we have to express y in a power series format, which was described in the working rule. And we have already said that is p is not equal to infinity and q is not equal to infinity for x is equal to 0 and x is equal to 0 is an ordinary point. The next step is to calculate dy by dx and d square y by dx square. But we have to note that here the nth term will be, for example, this one 7 a7 x to the power 6, 8 a8 x to the power 7. So nth term will be n an x to the power n minus 1. We can also express this one in a summation format, which was described in the working rule, means y is equal to sum of a k x to the power k. And then you can calculate the dy by dx again in summation form and dy by dx in again in summation form. But we can also calculate, that is in this format also, that is a1 plus 2a2x plus 3a3x square in this way. So we can also write the nth term. It has not been written here, but you can write here, that is n an x to the power n minus 1. Similarly, here also d square by dx square we have to calculate from this series, and again you can show the nth term for the d square y by dx square. Now what you have to do, you have to substitute the values of dy by dx and d square y by dx square in the given differential equation. So after the substitution, we have to do a little algebraic rearrangement. So you have to do the rearrangement in such a way. You have to separate the term x to the power 0. 2a2 means this is multiplied with x to the power 0, because x to the power 0 is equal to 1. This is a constant. Next you see that this is x to the power 1, and this is x to the power 2, and this is x to the power 3, this is x to the power 4. That it means that you have to rearrange this expression in such a way so that we write this expression in powers of x starting from x to the power 0. This is x to the power 0, next x to the power 1, x to the power 2, x to the power 3, in this way. And lastly, you have to write a term for x to the power n. So it will be easier if you show the nth term here, then it will be easier to calculate the nth term for x. Here you see it has been written a n minus 2 x to the power n. So why a n minus 2? Because when you will show the term here, then you will see that in the first case this is n, a n x to the power n minus 1. Then if you again differentiate it, so it will be n into n minus 1 into x to the power n minus 2. So as in the d square y by dx square term, this is x to the power n minus 2. So to obtain the coefficient of x to the power n, we have to move two terms earlier. That is why it has been written a n minus 2. I will make it clear in the next example, but right now just you have to know that this is the coefficient for x to the power n. Now what you have to do after rearranging this expression in powers of x, you have to equate to 0 the coefficients of various powers of x. You see that there are various powers of x here. So you have to equate the coefficients to 0 for the various powers of x. So first you see that in the right hand side, that is 0. So this is the coefficient for x to the power 0 is 2a2. So 2a2 is equal to 0. It means that a2 is equal to 0. Next, the coefficient for x to the power 1 is 6a3, and you have to make it 0. So 6a3 is equal to 0 means a3 is equal to 0. Next, coefficient for x square, it is a0 plus 12a4. So you have to make a0 plus 12a4 is equal to 0. It means that a4 is equal to minus 1 by 12 into a0. And similarly, you have to continue the process. And in general, what we have to show, that is the coefficients for the nth term is equal to 0. So when you make it 0, you will obtain a generalized expression. You see, the generalized expression is a n plus 2 is equal to minus of a n minus 2 divided by n plus 1 into n plus 2. Now from the structure of this expression, you see you can start calculating the coefficients for a starting from a4. Why a4? Because you see, if we put n is equal to 2 here, so it will become 0, a0. A0 is actually the first coefficients, because the series started from a0. That is why if we put n equal to 0, n equal to 0 is a minimum value. So then right side will be a0 and left side will be a4. So you can calculate values of a4, a5 starting from a4 here, because if you write a4, then this side will be a0. Otherwise, value of a will be negative, that is insignificant. So what you have to do, you can calculate the values of different values of a starting from a4, because if we put a n is equal to 2, then right side will be minus of a0 divided by 2 plus 1 into 2 plus 2, that means 12. So a4 is equal to minus 1 by 12 into a0, which was already calculated here. So directly we have calculated up to a6. Next we can calculate from starting from a7 here. However, we can also show that values of a4, a5, a6 from this expression, but we have calculated a4, a5, a6 directly. So you can calculate starting from a7, a8, a9. In this way, you have to show sum of the terms as far as you can. In this example, they have shown up to A12. Then what we have to do, we have to substitute these coefficients in the given differential equation, because the standard format of the given differential equation, the solution of the given differential equation was this one, that is y is equal to a0 plus a1x plus a2x square in this way. So in this expression, we will put the values of the different coefficients which we have calculated here. So after putting the different values of the coefficients and after a little bit simplification, we have obtained these solutions. This is the solution of the given differential equation. Now let us take another example. Suppose this is the differential equation. So in the first step, what we have to do, we have to express it in the standard format. So what we have to do, we have to divide the expression by 1 minus x square. Then d square y by dx square minus x by 1 minus x square dy by dx plus 4 by 1 minus x square into y is equal to 0. This is the standard format of the differential equation. So p is equal to x by 1 minus x square and q is equal to 4 by 1 minus x square. And clearly for x is equal to 0, p is not infinity and q is not infinity. So x is equal to 0 is an ordinary point of the given differential equation. Now we are assuming that y is equal to sum of a k x to the power k. That means y is equal to a0 plus a1x plus a2x square. This is the solution of the given differential equation. So y prime will be the differentiation of the sum of a k x to the power k, that is a k into x to the power k minus 1, and y double prime will be sum of a k into k minus 1 x to the power k minus 2. We will solve the differential equation in a little bit different way. That is, we will substitute this summation form to the given differential equation. In the earlier, we have expressed the series separately, but here we will substitute the values of y prime and y double prime in the summation format. You see that these values were substituted in this given differential equation in the summation format. So after simplification, we are obtaining, that is x to the power k minus 2 and its coefficient is a k k into k minus 1 minus sum of a k x to the power k k square minus 4 is equal to 0. That is, after simplification of this expression, step by step we have obtained this expression. And you see that in this expression we have used the summation format. Now what is our aim? We have to equate the various powers of x to 0. So at first what we will do, that we will equate the coefficient of x to the power k equal to 0. So if we want to put the coefficient of x to the power k is equal to 0, you see that here it is x to the power k and the coefficient is a k multiplied by k square minus 4. But in the first expression, this is x to the power k minus 2. But this is for various values of k. Summation means k is equal to 0 to infinity. This is the range of the summation. So if we want to calculate the coefficient of x to the power k is equal to 0, then what you have to do? You have to put k plus 2 for k in the first summation, because if you put k plus 2 in place of k, then it will be x to the power k plus 2 minus 2, that means x to the power k. Because unless you put k plus 2 for k in the first summation, we will not obtain the coefficient of x to the power k from this first term. So in the first term, we have substituted k plus 2 in place of k. You see, that is ak, we are writing ak plus 2. Then k, we are writing k plus 2. Then k minus 1, it means k plus 2 minus 1. That means k plus 1. Minus, here it is x to the power k. So directly we can write ak into k square minus 4, and that is equal to 0. So from this expression, we are obtaining the relation between ak plus 2 and ak. The relation is ak plus 2 is equal to k minus 2 by k plus 1 into ak. This relation is sometimes also known as recurrence relation. So from this relation, we can calculate different values of A. So you see that if we put k is equal to 0, then you will obtain A2. A2 is equal to minus 2A0. If we put k is equal to 1, then you will obtain A3. For k equal to 2, you will obtain A4. And in this way, we have to calculate different values of A. So in this example, they have calculated up to A6. So after this calculation, you have to put the various values of A in the series that we have assumed. That means y is equal to A0 plus A1x plus A2x square and so on. So in that series, we have to substitute these values of A. So after the substitution, you have to simplify a little bit. That is, you have to express in powers of x. So this has been expressed in powers of x, and after a little bit simplification, we have obtained this solution. So this is the solution of the given differential equation. So there are different types. There may be different types of differential equation, and we can solve this. Let us take a little bit different example. Suppose the equation is y double prime plus x minus 1 whole square y prime minus 4 into x minus y is equal to 0. Now you see that they have asked to solve this equation about the ordinary point x is equal to 1. Now, here we will use a trick. We will assume that this has been expressed x minus 1 whole square. So, we will assume that x minus 1 is equal to t. So, x is equal to t plus 1. So, dy by dx is equal to dy by dt into dt by dx, that is equal to dy by dt. So, d dx is equivalent to d dt. Similarly, d square over by dx square is equal to d dx by dy by dx is equal to d dt of dy by dt is equal to d square over by dt square. So actually what we have done, we have just converted the given differential equation in terms of t, and we have assumed that x minus 1 is equal to t. So after this conversion of the given differential equation, this equation can be expressed in this way, that is d square y by dt square plus t square y prime minus 4t into y is equal to 0, and clearly t is equal to 0 is an ordinary point. Now what we will do, we will solve the equation, and just like the previous process, at first we will assume that is y is equal to a0 plus a1t a2t square. Here you see that the series has been expressed in terms of t, as we have converted the given differential equation with respect to t. So we have to calculate then y prime, then y double prime. You see this is the nth term. I told before that is it is better to write the nth term in each series, so it will be better to calculate later. So this is the expression for the nth term here in y prime and y double prime. This is the nth term. Then substituting this value in the previous given equation, so you will obtain this equation. And now what we have to do, the next step, we have to equate the coefficient of various powers of t to 0. So starting from the t to the power 0, you have to calculate step by step, and that is you have to equate the coefficient of various powers of t to 0. So in this example, the coefficient of t to the power 0 means this term 2a2. 2a2 means 2a2 into t to the power 0. So 2a2 is equal to 0 means a2 is equal to 0. The next term is, that is coefficient of t is equal to 0. So you see there is a t term here, 3 into 2 into a3, and another is here, and that is 4t into a0. So then you have to equate the coefficient of t is equal to 0. Then you will get another relation. In this way, step by step, you have to continue, and you can calculate various values of a from equating the coefficients of various powers of t to 0. These are the various values of a, and later and last you have to equate the coefficient of t to the power n is equal to 0. And I have already discussed earlier, that is how to calculate the coefficient of t to the power n is equal to 0. So you have to find the nth term. This is the nth term. but you have to check, that is power of t is n. For example, here you see that although it is t to the power n, but it is multiplied by t, so actually it is t to the power n plus 1. So just previous term of this term is the term that contains t to the power n. So you have to find very carefully the coefficient for t to the power n. So this is the coefficient for the t to the power n. So and you have to make the coefficient is equal to 0, and therefrom you can get a generalized expression. This is the generalized expression or the recurrence relation. So you can calculate different values of a. For example, they have shown starting from a7, a7, a8, a9 from the generalized expression. So after we have to substitute different values of a in the given power series expression for the a. So after the substitution, you will get a simplified expression. This is the simplified expression. But lastly, you have to convert t to x again, because we have assumed that is x minus 1 is equal to t. So this is the solution of the given differential equation. So from these examples, I think you will understand that is how to calculate the solution of a given differential equation when x is equal to 0 is an ordinary point. Thank you for listening, and I request you to go through the textbook of Das and Verma. The name of the book is Higher Engineering Mathematics, for more clear understanding regarding the solution process. Thank you all.